The city of Ann Arbor, Michigan is located within the Huron River watershed. In parks and trails, the community interacts with the watershed in healthy, visible ways. However, in spaces we don't normally associate with water, stormwater is hidden underground in pipes, surfaces are impermeable, and detention ponds are engineered and inert. But what would it look like if we treated the water that lands here with the same amount of stewardship as the water that lands here? As the city of Ann Arbor develops its new comprehensive plan, disagreements over zoning strategies have emerged between pro density advocates and neighborhood preservation groups. Considering the broader environmental, social, and historical context of this debate could help guide decision makers. The Anishinaabe have lived in southeast Michigan for centuries and used these lands around the Great Lakes for hunting and gathering. They call the water Nibby and understand it as life itself and not just a commodity to be used. When European settlers arrived, the colonists divided up the land with the Jeffersonian grid with no regard for natural features. Ann Arbor's industrialization and residential development has led to degraded water quality, destroyed habitat, and increased sediment load in the watershed. In addition to the history, assessing the current stakeholder network was key to developing any design solutions. Ann Arbor is primarily zoned for residential uses, especially low-density single-family residential, or R1 zoning. Currently, the city requires developers to meet specific stormwater management requirements. In most cases, developers meet the requirements through engineered solutions that socially and environmentally disconnect the community and the land from the role in the watershed. Adjusting development requirements could transform R1 zoning neighborhoods from places of social and environmental disconnection to places of connection. As a case study, we selected the North Sky neighborhood, a single-family residential neighborhood in Northwest Ann Arbor. This development was built in 2018 and is largely characterized by its car-centric form, uniform homes, two-car garages, and expanses of lawn. Like most R1 developments in Ann Arbor, the stormwater is treated via engineered swales and retention ponds, undergrounded stormwater management, and monocultures of lawn.
Manicured lawns have become a symbol of home ownership in the United States. However, these lawns require substantial irrigation, contribute to water pollution by chemical use, and lack habitat for local pollinators. Our first strategy gradually transforms these lawns into an ecological patchwork of rain gardens. Like many urban developments in Ann Arbor, a homeowners association currently maintains the turf throughout the neighborhood. To implement the first strategy, the HOA will transform the lawns to rain gardens within all community shared spaces, while leaving a small area of lawn in the community park for children to play. Our strategy includes having public gardens, rain garden curbs, and shared vegetation along with traditional grass conversion. This will lead to lower irrigation costs, stormwater credits, and better aesthetics, inspiring other neighbors. As the ecological patchwork grows, the community gains biodiversity, healthier soils, and a strong identity connection to the watershed. Our second strategy reimagines stormwater travels throughout the site. As opposed to traditional methods of hiding stormwater in underground pipes and surface drains in the turf, our intervention creates a swale wetland network that also acts as stormwater commons for public use. The corridor decentralizes the runoff and creates moments of interaction with water throughout the site. The infiltration areas absorb more water into the ground, which allows the large retention pond on the south side of the site to become smaller and act as a community public space rather than a fenced off basin. These community spaces instill this feeling of shared responsibility for the watershed and their local ecology. Our strategy acts in multiple segments with the swale network to guide runoff and community spaces for people to interact more closely with water. Our third strategy provides mobility modifications to encourage alternative modes of transportation and reduce the negative impacts of car centricity. To encourage use of public transit, we propose introducing a new bus stop to routes 22 and 63 at the existing community park. We also recommend adding bike lanes and expanding the existing pedestrian pathways throughout the public spaces. To reduce negative impacts of car centricity, we propose replacing impervious concrete driveways with pervious pavers. Additionally, road chokers will be added at key pedestrian crossings to slow car traffic and beautify the pedestrian spaces. Our final strategy aims to transform R1 bedroom communities into places where daily life happens locally. This strategy could be implemented into future R1 developments, but we have reimagined what this would look like within North Sky neighborhood. A neighborhood community center becomes a hub for gathering, workshops, and casual interactions. Small businesses like cafe and corner market anchor walking trips and build social ties. These nodes increase walkability, allow more density, and reconnect residents to their neighborhood community. All of our design strategies can be used individually or as a combined system to reconnect the residents of Ann Arbor with the Huron River watershed. The North Sky neighborhood gives us an opportunity to see the impact of our design and rethink how one residential area can become a model for many. A place where an ecological patchwork, infiltration corridors, mobility modifications, and local night nodes build our connection to the watershed. These scalable strategies reveal what neighborhoods across Ann Arbor can look like when stewardship and watershed guide design.